Hello viewers, this is Ayush Tandon and you are watching India Ayush. Sorry, after a long time I'm making this a video, but I would like to share this problem on spring extension. So as you can see, this is a problem. We are given a block of M mass M is attached to this arrangement. There are four springs of different spring constants K1, K2, K3, K4, and we have to find what will be the extensions if we pull this block by a distance, suppose say x. Well, this is a good subjective problem, and if you want to try, you can pause the video and then you can try, and I think my answer is correct. Well, if you find any flaw, please do write in the comment section. This is a rigid support. So how to solve these questions? So basically, at first everyone thinks that it is quite a tricky problem because there are a lot of springs, and if you have to see, if you pull this block by x, then what will happen in this spring. So basically what will happen, you can relatively measure this. What we do, there is one method which is tension dot distance is equal to 0, net tension dot, because the net work done in this system would be 0, so the only work done here would be by tension. The net change in the work done would be here by the tension, but I'm not gonna use that trick because it sometimes fail, and I'm gonna use an conceptual approach towards this question. If we uh, elongate this block mass m by a distance x, that fairly means that we are pulling this pulley by a distance x. Now when I pull this pulley by a distance x, okay, and you have some springs, you have a spring here arrangement, and this is a block, okay. So now if I pull this by distance x, so this will come down like this, and there will be elongation here x as well, and there will be elongation in this part of the spring as well. But as you can clearly, you or we all know that in a string there is no elongation because it is not inextensible, but a spring is, because that's why you have these curve elongations, spiral elongations. So to compensate this elongation x, what the spring does is that it elongates by 2x and distributes x here, and it takes x for itself. So when we say that we displace such arrangement by a distance x, so we fairly mean that the reading in the spring balance would be, the elongation will be 2 times of the elongation that was in the block. So we can say here that extension in the spring which has spring constant k4 will be 2x, correct? Now, but please do remember that when this block will come by distance x, so here elongations will be x, but to compensate that, the elongation, net elongation that we will see in only spring uh, with spring constant k4, which is this one, would be 2x. Now see, this will try to uh, if you just pull this by x, so this will try to pull the rest of the spring by from a distance x. Yes, so it will try to pull down it, okay, so pull down. Now let us see this arrangement. Okay, so let us see this arrangement now. I'll draw here the arrangement. So we are given a spring which is k3, and then we have a spring k2, and then there is some purpose, so we will discuss that later on. And suppose I am here and I am pulling this by distance x, because that failure means this only, you can understand like this only, that I am pulling this by x. So if I pull this by x, what will happen is that you have to imagine this case. Now it's hard to imagine like this I am pulling it, so let's view this question, this part of the question, from the police perspective. What if I pull this pulley by a distance, say y? That fairly means that I am pulling this spring by that I'm bringing an elongation y in the K3 spring, correct? Now, this if I, so the after pulling this at a distance y, what will happen is that this pulley will come right here, yes, and when it comes right here, so this part will be also elongated by y, this part will be also elongated by y. But as you know that this is a string and this is a spring, so it has to compensate that y elongation here. So what it does, it elongates to y, because that's the property of the spring. Why do we attach it? So now we fairly see that to bring here elongation x, or sorry, to bring an elongation y here, we are bringing an elongation 2y in the K2 spring, and as a result we are able to observe a y elongation in the spring. So we can fairly see, or we can conclude from this state example, that if I pull this by x, this will be pulled down by x, and this will be pulled up by a distance 2x. I think this is clear till here. Next what I do is I observe this part of this part. Yes, let us understand this part also. Let us understand this part. So I'm drawing it here. I hope it is clear. And you have a spring, then you have a spring here. Now forget that this is a spring here attached. So I have brought an elongation 2x. I am standing here at a platform and I have brought an elongation 2x. So again we have to, for those of you who can just think of this, that if it pulls by 2x then this will be pulled by x, but I'm gonna explain you in an easier approach. Again I'm gonna do the same thing. Suppose if I pull this by a distance z, okay, pull this up or down, that fairly doesn't matter, but for explanation let us pull this by z down. So this pulley will come right here. If this pulley comes down by a distance x, so this distance will also be z and this distance will also be z. But as you again know, this is from attached to a fixed end, correct? If this is attached to a fixed end, we cannot bring this elongation, so the spring, see, so this spring will have to move to z. The spring will because I said that this string cannot extend itself, so this spring what it will do, it will elongate by distance 2z. That's the same case. Again I am repeating it here. Suppose what I said is that if I elongate this down by z, this pulley or this spring K1 and this was K2, that really means same, because K1 and pulley, because they are connected, their center of mass, the center of the pulley is connected directly to the string, the other part of the string is connected to the ground. So if I pull this by z, this whole part will come down by z and this spring will elongate to z. So to bring an elongation z here, because what fairly means is that when suppose it has spring initial natural length is x, so what it will do, it will elongate x plus 2z, or say delta z, suppose if the natural length of the spring is delta x, so the spring with spring constant k2 will elongate 2z, will elongate z itself and will distribute the other part. Suppose uh, I this is a black color spring and this is a red color string. So what I will observe by when I pull this pulley by z, that some part black part is observed here, and if you measure this part, this will be z. And if you just notice the elongation, suppose it has um, seven these spiral structures, and later on I observed that there are only say five, so I can fairly conclude that there is a it has elongated, and that is a test because if you can just observe it in the lab. So what I what the actual problem says is that if I long this K2 spring is elongated by 2x. K2 spring is elongated by 2x. So this K1 spring has to elongate by x. Yes. So that when it elongates, it moves x upwards. So this so there will be an extension of 2x in the spring K2, and we have solved the problem. But we are not done yet. Suppose if in the question it says that I have to arrange a similar setup in which I am attaching all the four springs directly, but what will be the spring constants of the spring? That means I am required to make an arrangement. I have a block of mass m, and I have some given as springs, four springs, and I'm asked to what are k dash, k double dash, k triple dash, and k four double dash. So now let's look at that part. Okay, so as you can okay, so I have changed the board here. I have redrawn the against whole structure, and I have depicted all the tension. Suppose if in the block mass m there is a tension 2t, so here there will be tension t, here will be there a tension t, t, 2t, tt, 2t. Yes, correct, because this is one whole part. Yes. So basically I need to arrange these, there are four springs. I have to determine what are the spring constants. Here I have shown what is the answer, but I will explain you how to get this. So there is a tension 2t in the block of mass m when I have elongated this by a distance x. So basically there should be a tension 2t acting in each of the strings, and these strings should be elongated by a distance x. That is the must condition. So let us write the equations. Let us observe the K4 spring. Here K4 spring there is a tension T, and it has elongated by a distance 2x. So what I have written? I have written T equal to K4 2x. Similarly, in the if you see the string K2, spring K2 with spring constant K2, and there is elongation 2x and tension T. So I have written equation T equal to K2 times 2x. Let us observe K1 and K3 similarly. So K1 there is a tension 2t and there is elongation x. So I have written 2t equal to K1x. And for K3, which is this one, there is elongation x, tension 2t. So I have written 2t equal to K3x. Now there should be each of the spring constant should be such that there should be a tension 2t in each of these, and there should be what? There should be an extension of x. So basically two of the springs should have spring constants k1 and k3. Why? Because they have tension 2t and they have extension x. Here if we carefully see, if I multiply these both by 2, by this also 2 and this also 2, so what I will get? I will get 2t equal to 4 k2x and 2t equal to 4 k4x. Yes. So that fairly means I brought a tension 2t and extension x in both. So I need a spring in which there whose spring constant should be 4k2 and 4k4 respectively, which I have shown here: k1, 4k2, 4k4 and k3. Well, this is the problem which I solved, and I loved this problem. This is a very conceptual problem, so I decided just to make a video to share the solution. The solution is very long, 15 minutes video, but let's end it right now. I hope you like this, and if you think the solution is wrong, or what method you have used to solve this to get this answer, please do share in the comment section. I love to know my mistake or what's the other strategy that you have used. I have not used it at tension dot x summation is equal to 0. That is also a trick you can use, but I avoid this and I try to solve this conceptually. Hope you like this. See you in the next video. Till then, take care. Bye bye.